Hello everyone. Today we are going to start our unit on trigonometry, and I want you to know this is one of my favorite units, but you also need to know that for trigonometry, this lesson, the very first lesson, is the most important lesson. You must get this lesson correct or you will not be successful in later lessons. So please make sure you fill in your notes completely and that you pay attention to this lesson and that you can refer back to your notes when you need to. So what is trigonometry? Well, simply put, trigonometry is the study of triangles. But more than that, it's the study of the measures of triangles. Specifically, the relationships between the angles and sides. And that's what we're going to set up today. Again, this is the most important lesson in this entire unit as it is foundational. So let's go ahead and talk about that foundation. Trigonometry is based around these three ratios. Every acute angle in a right triangle has these three ratios. These are the sine, the cosine, and the tangent. These ratios represent the relationships between the legs of the triangle in terms of the angle that we are looking at. And I know that can be a little bit confusing, so follow along and make sure you pay attention. If you need to go back, please stop, go back. You need to make sure you understand this part. Please focus on this part. All right, so we're going to try a couple of different techniques here. So we're going to focus on angle A before we focus on angle B. So what I'm going to do is I'm going to use my drawing tool. I'm going to highlight the angle that I'm interested in or trace it. So what I'm going to do is I'm going to take my blue color right here that I'm using, and I'm going to trace AB and AC. So what that tells me is angle A is made up of these two sides. You can also use an arc mark that goes across as long as whatever you're using to highlight the angle indicates both sides of the angle. Okay, we need to focus on these sides of the angle. So now what we're going to do is we're going to identify the three sides of the triangle in relation to the angle that we're looking at, in relation to angle A. Okay, so one thing that does help some people is to go ahead and cover the other angle completely. So if I do this where it's covered, let's go ahead and make that darker. It's easier to focus on what you're looking at. So I'm going to go ahead and cover that for right now. And I'm going to label my sides. For our purposes in trigonometry, we are going to refer to the sides as the opposite side, the adjacent side, and the hypotenuse. Now remember, again, opposite and adjacent are in reference to the angle. But the hypotenuse is always the side that is across from the 90-degree angle. Okay? So the first thing you should label each time is the hypotenuse. Just like when we were doing the Pythagorean theorem, I said, find your hypotenuse, label it C. Well, now we're going to do the same thing. You are going to find your hypotenuse and label it first. The hypotenuse never changes. Now, we're going to look at angle A. So there are two sides to the angle. We have this side, which is the hypotenuse, side C, and we have side B, lowercase b, which is right here. It is the angle in between those two sides that we're looking at. So that means this is the adjacent side. Remember, adjacent means next to. So this angle, this side side B is adjacent to angle A. It is touching angle A. It is part of angle A, and that is going to be the adjacent side. Now, the third side is called the opposite. Again, this is across from the angle that we're looking for. If I look at angle A right here, angle A right here, directly across from it is the side, lowercase a. Okay? You may remember back from our first unit, sides are lowercase letters. We use capital letters for angles. So we see right here, side A. So we're going to set up these ratios. I'm going to use the equation editor so that I can make vertical fractions. And again, I am focusing on angle A. So angle A, again right here, and we want to look at the ratio of the leg opposite the angle to the hypotenuse. So we're going to do the sine. I know it says sin here, that's short for sine. So what side is opposite side A? Lowercase a. So our numerator is going to be lowercase a. The ratio from the leg opposite to the hypotenuse. So again, opposite was A, hypotenuse is C. Okay. For cosine, it is the ratio of the leg adjacent to the angle to the hypotenuse. So if we look again at angle A, this side right here, AC, which is labeled with the lowercase b, is our adjacent side. So it's going to be B as the numerator, and hypotenuse remains C, and that will be our denominator in our fraction form. Finally, we have the tangent. Tangent, the ratio of the leg opposite the angle to the leg adjacent to the angle. So that is opposite over adjacent. So we look at our image here. Our opposite side was side A. Our adjacent side is side B. So A to B, or A over B, is going to be the tangent of angle A. Okay, so now I need to focus on angle B. So what I'm going to do now is I'm going to cover up angle A, right here, and I'm going to focus here on angle B. I am going to pick a different color to trace angle B. Again, we have our hypotenuse on one side, and now we have side A on the other side of the angle. And we can do our crossing here. Remember, you do not have to do both tracing and the arc. Again, hypotenuse is always the same. That is going to be the side across from the 90-degree angle. Adjacent is going to be the side touching the acute angle that we're looking at. So in this instance, angle B. And that means the last one is going to be our opposite side. If you always do something to highlight the angle you're looking at, the side that is not highlighted is the opposite side. Hypotenuse is always across from the right angle, and the adjacent side is one part of the triangle. Okay. So let's look at each of the ratios. First, sine of B, opposite to hypotenuse. Now our opposite is side B. And that is going to be over our hypotenuse of C. Then we have cosine of B, which is going to be adjacent over hypotenuse. So our adjacent side is lowercase a. Our hypotenuse is lowercase c. And again, finally, tangent is opposite over adjacent, opposite to adjacent. Opposite side in this instance is now B, and adjacent is now A. Now take a moment and look at the ratios and see if you notice any similarities or relationships between them. You might notice that sine of A and cosine of B are the same. Sine of B and cosine of A are the same. And tangent and A and tangent B are reciprocals of each other. All right, now what we're going to do is talk about the mnemonic that we will use to remember this. It is one of the mnemonics that gets stuck in your head the most. It is vitally important for this unit, and that is so, ka, toa, SOHCAHTOA. Any math teacher will know what this means. Any person who does math on the regular should know what it means. So means sine is equal to opposite over hypotenuse. Sine is equal to opposite over hypotenuse. Ka, C-A-H, cosine is adjacent over hypotenuse. And finally, toa is tangent is equal to opposite over adjacent. SOHCAHTOA. It is the most important thing you will learn in this unit in order to make this unit as simple as possible. If you can do the trigonometric ratios and set them up properly, this unit will be a breeze. All right, so what we're going to do is now we're going to do some examples, setting them up in numerical form and simplifying the ratios. We are going to be using the same strategy where we highlight the angle, and I am also going to cover the angle we're not currently looking at so that we can focus. I am going to also keep our sine equals opposite over hypotenuse right here, cosine adjacent over hypotenuse, and tangent is opposite over adjacent. So let's look at number 1. In triangle ABC, we have sides of 12, 5, and 13. So the very first thing we're going to do is we are going to find that hypotenuse. So let's look here. Here's our box indicating the 90-degree angle. Straight across from that is our hypotenuse, always. So I'm going to go ahead and label that hypotenuse. That won't change for either of our angles. Now I want to focus on angle A to start. So the first thing I'm going to do is highlight angle A by tracing it. Maybe doing the arc mark. You do not have to do both. You can do either. And then I am going to go ahead and cover angle C. So that it is not distracting me. So looking at angle A, just looking at angle A, we can see that this side that is 13, it's our hypotenuse, which means the other side that touches angle A is our adjacent side. And our third side that does not touch angle A at all is our opposite side. So just like we usually do, I am going to be making a list. Luckily, we have a bunch of different letters. So for this one, I'm going to just call this list A. I have my opposite side is 5. My adjacent side is 12. And my hypotenuse is going to be 13. So now I'm going to go ahead and look at the right here, sine of A. Sine is opposite over hypotenuse. Opposite is 5, hypotenuse is 13. Both of those numbers are prime, so therefore this cannot be simplified. Cosine of angle A is adjacent A over hypotenuse H, so 12 over 13. Again, we cannot simplify it because 13 is prime. And finally, the tangent of angle A. Opposite side over the adjacent side. O over A. So O is 5 and A is 12. All right, now it's time to focus on angle C. You will notice I have moved the box so that it covers angle A. Again, first thing I'm going to do is trace the angle that I'm looking at, angle C. My hypotenuse does not change. It's always going to be the same, so therefore I'm going to leave hypotenuse labeled as is. But now angle C is bordered by line B, segment BC and line segment AC. So that means this side right here, that is marked as length of 5, side BC, is going to be my adjacent side. That is the side that touches angle C. And then across from angle C, the opposite side is side AB, and that is going to be the length of 12. So again, we're going to make a separate list for B. Our opposite side is 12, our adjacent side is 5, and our hypotenuse is 13. All right, we have sine of angle C. Sine is opposite over hypotenuse. Our opposite side is 12, and our hypotenuse is 13. Cosine of C. Cosine is adjacent over hypotenuse, so we get 5 over 13. And tangent is opposite over adjacent. So our O is 12 and our A is 5. And again, you can see those same relationships where they cross. Sine of A and cosine C are the same. Sine of C and cosine of A are the same. And tangents A and C are reciprocals of each other. All right, now we're going to move on to number 2, triangle WXY. Now you will notice they did not give me my third side here. Now I can tell you this is a Pythagorean triple. It's a 3, 4, 5. We haven't talked much about those. So what I'm going to do is, right now, we are going to solve for the third side. So we have 9 squared plus 12 squared. Oops. And that is going to be 81 plus 144. Okay, and that's 225. If we take the square root of that, we get 15. I'm just going to put this right here. Okay. All right, so again, that tells me that our hypotenuse is 15. So again, the first thing we're going to do is label that hypotenuse as such, HYP, because again, the hypotenuse does not change based on what angle you're looking at. It only the adjacent and opposite sides do. Okay, so let's focus on angle W right here. First thing I'm going to do is highlight. And then I'm going to just borrow this box here, cover up angle X so I can focus. I'm looking at angle W. The hypotenuse is already labeled, so therefore the other highlighted side is my adjacent side. It is the side touching the angle. And then, of course, the side that is not touching the angle is going to be our opposite side. So we're going to make our list. Our opposite side is 12. Our adjacent side is 9. And our hypotenuse is going to be 15. All right. So looking at sine of W, opposite over hypotenuse, 12 over 5 over 15. Now that is not the simplest form, as both of those numbers are divisible by 3. So that is going to be 4 over 5. Again, if the simplifying fractions doesn't always work out so well, then you can put 12 over 15 into your Desmos calculator, click on the fraction conversion button, and it's 4 over 5. Okay. Cosine of W. Cosine is our ratio that is adjacent over hypotenuse. Our adjacent side is 9. Again, our hypotenuse is 15. That gives us 3 over 5 as our ratio. 9 over 15 is equal to 3 over 5. And finally, the tangent of angle W. And that's going to be our opposite side over our adjacent side, which is 12 over 9. Again, both divisible by 3. So this is going to be 4 over 3. All right, finally, let's go ahead and focus on angle X. Okay. Oops. All right, so apparently it wants to keep that ADJ available, but that's okay. We're going to go ahead and highlight angle X. And then we're going to label the sides accordingly based on their relationship to angle X. Hypotenuse does not change. Again, now this is a side that is touching the angle, so it is now our adjacent side. You may notice I'm using the same color to do the angle and the opposite and adjacent. And again, the side that is not highlighted, the referenced angle, that is not part of that referenced angle, is going to be the opposite side. So we're going to make a list for X. Our O is 9. A is 12, sorry. And H is 15. Right, and then what we're going to do is use our equation editor and put in the ratios. Sine of X is going to be 9 over 15, which again is equal to 3 over 5. Our cosine of X is going to be 12 over 15, which is going to be equal to 4 over 5. And then finally, our tangent is going to be 9 over 12, which again is equivalent to 3 over 4. Now I want you to stop and think for a moment. If I told you I did not look at the triangle once to do these problems right here, how would I have done that?